So, David, what is the latest understanding of the dark matter problem?
We don't know what makes up most of our universe.
Okay, that's it. We're done here. What about the famous monochromatic tic-tac that everybody saw?
There's stuff out there like that are just amazing things we don't fully understand.
Why would the government hide this?
Government agencies leak. And if anyone's going to get more funding from the leak, it definitely leaks.
That's the answer right there. This is StarTalk. Neil deGrasse Tyson, your personal astrophysicist. Chuck Nice, right here with me.
Hey, Neil.
All right, man. You know what we're going to do today?
Yeah.
Oh, my gosh.
Yeah.
Okay.
We got a good one.
We got a good one.
We got a good
one. You remember what happened to UFOs? They got rebranded by the government to UAPs. Yeah. Unidentified aerial phenomena. Yeah. And I had an inside guy on that operation. Just the fact that it came to the attention of Congress. Let me introduce all of you to my friend and colleague, David Spergel. David.
Pleasure to be here.
Welcome to StarTalk. Dude, we came up together in graduate school, and we intersected more thoroughly when I was a postdoc at Princeton. And he was on the faculty there and then became chairman. And I knew him when he was just a scientist. Now he's running everything.
Right,
okay?
Exactly.
I'm looking at what my boy is running. So you chaired NASA's UAP, Unidentified Aerial Phenomena, Independent Study Team. You chaired that. But that's not, you're president of the Simons Foundation. We'll get more into that later. You chaired the Science Definition Team for the Nancy Grace Roman Telescope. Okay? We'll get more about that if we have time. And you're also on the board of trustees of the Carnegie Institute for Science. Carnegie, isn't that the same group where Edwin Hubble worked for them?
Yep.
This is a long legacy.
Long and really impressive tradition.
So, David, how did you morph from Mr. Head Honcho Scientist, big man on campus, to alien UFO guy for Congress?
Approached it the way we approach scientific questions.
Okay.
Approach it the way things we don't understand. So you look at the data you have, and you realize much of the data could be explained. Balloons, drones, anything with flashing lights is an airplane. You know, aliens who are coming here who want to be hidden, don't put flashing lights on them.
Right.
On their UFOs.
Exactly. Like undercover cops. They don't, you don't see an undercover cop in a marked police car
with sirens,
blazing and lights flashing. Right.
Okay. But that doesn't preclude the possibility that an alien craft would have flashing lights. In fact, the mothership in Close Encounters of the Third Kind had tons of flashing lights.
Nothing but flashing lights. It was like a doggone disco in the sky.
It was a disco
crazy
ball in the sky.
Yeah, I'm not sure flashing lights really make sense for a spaceship.
Okay.
But anyway, there's a bunch of things that look, when you look at them carefully, they're camera defects. I think we've all taken pictures of people where the sun glint got in and ruined the picture.
Correct.
So there's some like
Lens
that.
flare.
Lens flares, right? And then you go through.
I think if that's happening a million times a day,
right,
something in there is going to be interesting.
Yeah.
You're going to find Jesus in one of the lens flares.
Yes.
Right?
That's my religion.
And then you look through that, and then there are some things we don't understand.
Okay.
Right. So there's some events.
Approximately what fraction?
About 1%.
1%?
1%.
Yeah.
All right.
Okay.
It's about 1% of the events, and the military had a study that went through this. We used a lot of their work. About 1% are not understood.
Wait, can we back up for a sec? Who appointed this committee?
NASA.
NASA. Okay, gotcha.
So this is to give advice to NASA on how they could help advance our understanding.
Was this requested by Congress?
No, it was requested by the head of NASA.
Okay, so NASA wants to play in the sandbox.
Right. Yep.
Yes, okay. Mm-hmm. And NASA is among the most transparent agencies.
Absolutely.
And
they have no reason to, they don't have an agenda.
And
right.
There was nothing about our study that was classified. I have no clearances. Mm-hmm. So we can talk openly about everything we did. And we looked at what the events that we didn't understand. That
By the
1%.
way, when you have the highest level of clearance, that's what you would say. You say, I don't have any clearance.
But I don't have any clearance.
That's exactly what a high clearance person would say.
Right.
No, go on.
the data was ambiguous. We didn't understand it, but it wasn't like it was something clear. And one of the points we made was, as scientists,
Again, this is the 1% that we don't know what they are.
yeah,
Yes, okay.
yeah, no, and when you don't understand something, you don't jump to the most exciting conclusion.
Right.
You don't say it's got to be aliens. You look at it and say it's something I don't know, but you don't ignore it either, right? You should not ignore things you don't understand. If there are things you don't understand, what do you want to do? Get better data. And that really was our message to NASA. If they wanted to contribute to this, they should help get better data. Right now, everyone is carrying in their back pocket a device that takes really high-quality digital images,
Yes.
accurately records the time,
Yes.
measures GPS position,
Correct.
measures the local magnetic field, measures the local gravitational field.
Did you do all that?
It does all that. That's why it knows how you're orienting your phone.
Clearly, that's not an Android.
So, hey, I've got an iPhone. I think, and there are billions of them around the planet.
So you're saying when it knows which way is north, is it using the magnetic north, or is it correct? It's got to correct for that.
It's got to correct for
Okay,
that.
so it
It's
knows
got-
where I am on Earth,
Right.
corrects for the magnetic anomaly,
north
is what we call
right.
it. And then it
and then
gets
gives
me
you the true north.
the true north. Good.
Okay.
Yep, and gets it. It is really amazing what that device measures your phone. And if you can imagine, if we had pictures of something we didn't understand, taken by citizens from a whole bunch of different perspectives, you can
Different sight lines.
Different sight lines. You'll be able to reconstruct the event.
Okay.
To know how fast the object is moving, how far away it is.
And not be susceptible to someone's capacity to interpret what they see.
That's right.
Right.
So it's not a single blurry image, but tens of high-quality images. And you don't have to worry about things like camera flares because you've got multiple cameras
images.
and multiple images.
Okay.
So our recommendation to NASA was to develop an app. And to develop
There's an app for that.
Oh my gosh.
Okay, what's the app?
It doesn't exist yet. So
Okay.
this was our recommendation
All right.
that they fund the development of something like this and that they use this to collect more data.
So I'd have the app on my phone. I see something I don't understand. I take a picture, and the metadata in that image, I just upload it to the app in some simple way. Do you want it simplified as much as possible? And then that goes to a central place. And then you can have people there that can collate and correlate the data.
And we said just try to make everything public.
So you're crowdsourcing the data gathering itself.
Yep.
Okay.
So
People are everywhere.
Yeah.
people are everywhere.
Right.
And I felt this was a teachable moment, a chance to say, what do we do as scientists? We collect data, we verify data, we check data quality. I did a bunch of TV interviews on this. As soon as I started talking about checking data quality, they ended the interview. They wanted to hear about aliens.
yeah, don't be so boring, dude.
But it's like, you want to make sure that people didn't put in fake images.
I just love it. He's just like, of course, we gather data. We check data quality. They were like, this guy has integrity. Get him the hell out of here.
No, but what you're saying is, in an era where we have Photoshop and even more advanced, and even
Right.
AI generating images, you want to make sure you need some way to authenticate
Yeah.
what the camera caught.
And that didn't even occur to me. See how I'm thinking, yeah, you take a picture, but the fact is that those Photoshop type programs, they exist on your phone. You don't have to actually go.
Right.
Like you could just hit a button on your phone and start manipulating an image
In the
right
old
then and
days, you
there.
had to take
you had to go take it
picture
and
on the-
import it someplace.
To your computer, mess with it, and put it back
No,
out.
now you can just do it right when you take the picture. So
Yeah.
that makes sense.
No, I mean, it's not hard to take a picture shaking the hand of a friend and replace the picture of the friend with, I don't know, Dr. Spock, whoever your favorite alien is.
Yeah. That would be mine.
Spock was half alien, I think.
That's true.
Yeah, he's
That's right.
human.
Half Vulcan.
The mother was...
On this show, we have to be very accurate about that.
Mom was human. Dad was
That's all I'm
Sorak.
saying.
Yes.
That's all I'm saying. So you presented your results more than a year ago. What has happened since then?
You know, NASA's considering developing these things. To do that needs new money.
Oh, yeah, okay. A little pot of money.
And last year was a very tough year for NASA's budget.
All right.
NASA took a huge budget cut.
I remember that.
Yeah, so they had to cancel programs.
Yes.
So they were not about to start something new. I mean, when we started, they thought there'd be some new monies from Congress. They'd be able to say, here's a program that would be, we would go to the community. And we thought about that as like, here's something NASA could do that would involve citizens.
Yeah.
And they just, at a time at which they were canceling missions, they just did not want to do anything.
Okay,
That's really a shame.
But at least it's on the radar that it's something to do if money then becomes available.
Yep.
Okay.
In a way, don't you think that's a big mistake? Because here's what I'm picking up from what you're saying. You are immediately enlisting the public and getting people to focus on NASA. You're getting them excited about the one thing that everybody can agree is exciting, which is, are we being visited? And you're saying, okay, here's an app, get involved. Like, I would take money from someplace else and put it into that.
Yeah, but we also said, which I think is true, we did not see any convincing evidence for the existence of aliens.
Okay.
Now,
see, there's your problem. You didn't lie.
and not seeing convincing evidence doesn't mean it doesn't exist, but that means there's no convincing evidence.
Absolutely.
I know you very well as not only a friend, but as a fellow astrophysicist. So we have very strong overlap in our training and our brain wiring. You don't want everyone on the committee to have exactly that same brain wiring. So who else was on the committee? What was the nature of their expertise, and who selected them?
I was selected by NASA. I was involved in advising as committee chair who was there. So we had a pretty diverse set of people coming from oceanography, atmospheric science, because there's a lot of atmospheric phenomena, and so experts on the ionosphere, some science policy people.
The ionosphere, a layer of the upper atmosphere that is
Charged.
ionized.
Right.
Yeah.
That's where we get the northern lights?
Yep.
Does that happen in the ionosphere?
Well, I may even be higher.
Yeah, it does?
Yeah, does it? Yeah,
But it starts there and it goes. The ionosphere is usually above that,
Right.
So a lot northern lights are usually a bit lower, but it's connected phenomena.
Okay.
And
certain radio frequencies of radio waves reflect off of the ionosphere. Interesting things can happen with the ionosphere that wouldn't happen in any other layer.
Oh.
Yeah, it's pretty wild. Okay, so go on. So
we had some people from the intelligence community, right? Because they have a lot of satellites looking down.
Okay. So they would have had clearance even if you didn't.
That's right.
Yes, okay.
We had some
in their own business.
In their own business. We had some people from technology companies.
Good.
Right.
Who were familiar with some of the technologies out there, some of the things we can use from space to look down and see what was going on. We had to.
So some thought went into this.
Yeah,
That's very encouraging.
lots of different perspectives around the table.
Right.
It was actually a really good group of people that I learned a lot from.
As we've learned from David and his team, one of the most exciting things about scientific discovery is that even when we don't find all the answers, the process can bring us closer to the truth. Take this recent TRAPPIST-1 study, for example. Scientists completed the longest search for signs of alien technology. And although they didn't find any, their effort established a new method for future searches. Being open to new ideas and always refining your research is the most important lesson here, something our longtime partners at Ground News really help with. They're a small team, led by a former NASA engineer dedicated to adding clarity to an often contradictory media landscape by calculating how credible every source reporting on a story actually is. With very high being the gold standard of responsible journalism, all the way down to very low, so you can easily distinguish fact from fiction. And if you want to dive even deeper, Ground News daily briefings break down the day's top stories by clearly highlighting facts, points of agreement, and even opposing views. Exposing yourself to diverse viewpoints ensures you're not just critically informed enough to think you're right, but to even challenge your assumptions and grow. So, if you're just as curious as us, subscribe to Ground News today or gift this to someone you know. We're giving our viewers 50% off their Unlimited Access Vantage plan, their biggest discount of the year. Just go to ground.news/StarTalk or scan the QR code. We really can't recommend them enough. Now, let's get back to the show.
All right, so you had your role in the hearings, but did you watch all the rest of the hearings?
I watched some of it, not everything.
Yeah. Do you have any thoughts or reflections?
there are some amazing things that came out that were fun to watch. I don't know if you remember these bodies that were of aliens that were shown to the Mexican Parliament.
The Mexican Parliament. Yeah, the Mexican mummies. The Nazca mummies in Mexico put on display. They're like 3 feet tall.
Right.
And there's like 2 or 3 of them. Yeah.
Yeah. And they were
that came out while you were,
that came out while we were doing it.
Yeah.
And that was one of these things you look at and say, wait a second. If you actually have something that you think is interesting, what you should do with it is send samples around, right? Like, send the samples to 100 labs around the world. Okay. And if it's not human DNA, we'll find out quickly.
Without the bias that might be inherent in who produced the bodies.
Right.
But in addition, when I saw that, I said, that's exactly what we should be doing if we have crashed alien bodies. We should put them on display. But no one did that. In the testimony, everyone kept saying, those who claimed it existed said it's in a locked box, and then you can't come and look at it. And I thought to myself, an alien in a locked box that you're not showing anybody is the same thing as no alien in a locked box
that you're not showing.
Scientifically, it's the same thing.
Right.
So how did...
Can I ask something? To both of you.
Yeah.
What would be the impetus for not showing the fact that these aliens exist? Why would the government hide this? If, because conspiracy theorists have their own, but why?
I'll turn it around.
Go ahead.
I've worked with government agencies for a long time. Government agencies leak. And if anyone's going to get more funding from the leak, it definitely leaks. So I'm running a lab.
That's the answer right there.
So I am running a lab that had some secret alien stuff. If it leaks and there's lots of information and the alien bodies are shown, I get more funding.
Of course.
So one of the reasons that I don't believe the conspiracy theorists is I trust people to look out for their own economic self-interest. And, the government leaks everything all the time.
My favorite quote is from Ben Franklin, from his Poor Richard's Almanac.
Yes.
He said, 3 people can keep a secret if 2 of them are dead. There it is.
Right.
The foundational documents of the country.
Yeah, that's it. Right.
But why didn't they bring forward what...
Maybe they don't exist.
Oh, okay.
Right. Yeah.
Okay. So the big concern is there could be some kind of alien technology that is so far beyond us that it could pose a security risk. And you're saying even in the 1% of the things you could not explain, there was nothing there that, whoa, this could be future technology. Because think about what anything today that's flying through the air would look like to anybody 100 years ago. So it doesn't take much time, Delta, to possibly freak someone out about how advanced you are.
Yeah. So that's part of the story of Area 51, right? Which was our military was developing advanced technologies, and those were secret.
This is a Cold War. Yes.
Cold War.
Yes.
And think about drones. Imagine you saw a drone 25, 30 years ago.
Right.
You'd never seen one.
Right.
Just moving.
Just moving in any direction that it wanted.
Up and down.
All along any axis.
Any axis instantly.
Instantly.
Yes.
You would think a drone, and with no human in control.
Right.
You would think a drone that we're totally used to is an alien spaceship. Right. And, so there's technologies out there. If you look at a lot of the reported events, there are a number of them those events were associated with things seen by military pilots. And you have to ask yourself, who is going to be trying to see what our military pilots are doing? They fly all the way here from some other planet to study our planes deployed outside of Taiwan? Or is it the Chinese? And one of the things that came out during our study, you may remember this Chinese balloon?
Yes.
Right.
We love the Chinese balloon.
Yeah.
Right. So it is very clear that the United States...
Did we shoot it down? We shot it down.
We did. We shot it down.
The United States is spying on the Chinese military. The Chinese are spying on the U.S. military. This is like their job.
Right.
And so part of the security value of monitoring and getting this information. If I remember correctly, back in, was it the 60s, the government did not disavow UFO sightings. They wanted to promote people's awareness of them in case they saw something that Russia was sending over. And then we get firsthand knowledge because people are everywhere and the military isn't. And so there was strategic value to this as far as the military is concerned. That's still the case.
You know, you look at the war in Ukraine, and both the Ukrainians and the Russians are relying on citizens following drones. They've got apps on their phones.
That's right.
When you see a drone fly over, so they know to shoot it down.
Yeah.
So where are we now in this? Why were there still hearings just a few weeks ago, a year after these other hearings, when I thought everything got aired as much as it needed to be?
You know, I think people like conspiracies. People want to believe.
Mm-hmm.
Yeah, they do.
And people are not comfortable with ambiguity, right? To say, you know, we look at lots of data and there's a few things we don't understand. They'd rather jump to some exciting conclusion
Then just sit
do
there
the
in
work.
ignorance.
Yeah, it makes you feel better, though. You know,
Every science, you hit something you don't understand, that excites us.
Right.
We don't immediately come up with an explanation. We might have an hypothesis, but not without justifying it with more data or better data.
I mean, let's be honest. Most people are not scientists. Most people see a splotch on a piece of toast and they're like, "It's Jesus." So let's be honest.
I've seen some pretty good Jesus renderings, though. There's some good ones.
There's been some good ones. You know,
It's Renaissance Jesus, though.
Yeah, well, it's always.
That's what he was most painted, probably.
Right.
Yeah, you know, Jesus in most of those paintings looks like he's from the local town. There's a lot,
Isn't that funny?
A lot of blonde Jesuses.
Right. Yeah, that's so funny. Yeah, you never get Afro Jesus
Afro Jesus.
on the piece of toast. Pull the toast out the toaster oven. I couldn't believe it. Afro
And
Jesus.
since Jesus was Jewish, it'd be a Jewish Afro.
It would
right?
be.
Right. That's how that would have happened.
Yeah.
Definitely. Now, in our field, in science in general, we greatly devalue eyewitness testimony if we have another way of obtaining the data. With UFOs, it's kind of only eyewitness testimony because it comes upon you, not when you're all ready with measuring equipment. And so apart from the smartphone, what else does someone have to offer you but the eyewitness testimony that they've experienced?
Eyewitness testimony is just not very reliable. I mean, this is something that we've learned about.
Talking to a black man here. Just saying.
Yeah, so there's a lot. I mean, this isn't aliens, right? This is just a lot of court cases of people who were unjustly convicted.
Positively identified. By eyewitness.
By eyewitness, and then...
And even without malicious intent, sometimes malicious, but most times not. Just people going, no, that's him. That's the, or because they were shown something, shown a
With
picture.
the lights on? No, actually.
Right.
Right.
Yeah. I was 3 blocks away.
You know, and there's just lots of problems with eyewitness testimony.
Right.
And I think this is actually more important for understanding things in the context of our justice system than
For
aliens.
UFOs, right, of course.
Right. But we have cameras. And we don't only have to have cameras. We have early warning radar systems. I mean, when we step back and think about what data does the military have, what data does the scientific community have, we are monitoring space and the environment around us all the time.
And I further add to that, I think I ran the numbers on this, there's 1 million people at any given moment who are airborne with a window right sitting next to them.
That's right.
And so if the mothership is coming, we can totally crowdsource that.
We also monitor everything coming into the solar system.
Right.
So if there is something big coming into the solar
This
system,
guy's got more power than I knew.
we'd see it.
Yes.
Well, the military certainly monitors everything flying into the U.S.
Right.
You cannot fly a plane from, Europe to the U.S. without someone noticing.
Right.
Right. So we're monitoring a lot around us. So we do know a lot about our environment. And as we go through all of that data, and lots of people have done this, there isn't any convincing evidence of advanced technologies beyond what we have.
So what about the famous monochromatic tic-tac that everybody saw? of the F-18 Navy pilots that reported, and you hear them go, "Oh my gosh,
Yes.
what is
Yes,
that?
It's an orb, and it's moving.
What is
and,
it?"
Right.
Yeah.
and-
So we don't know the distance to the object.
Why not? Don't they have tools that get distances? They need a new airplane if they can't know. I'm sorry.
Well, no, they don't. You know, the data quality for those events were not terrific. You'd like to have more measurements. Those, you know, I said there's a percent, you know, there's a percent or so that we don't understand. That is like absolutely part of that, right? That's one of
the centerpiece of the 1%.
That's one of the centerpiece ones. And you look at it and say, that's strange. Next thing you think is, let's get some more data.
Yeah.
How far away is that? How fast is it moving?
Right.
Right? Could that be explained by conventional technologies, by balloons far away? Is there something normative it could be? We don't know. We need better, you know, but the data we have is pretty
I heard
unclear.
someone in the security space suggest that wouldn't this restricted airspace be an ideal place for the military to just put an anomalous object into the sensors to just see how their pilots react?
A scrimmage test.
Scrimmage? Oh, yes. Yes.
Yeah. It's
see what they do.
what they do.
Do they try to shoot at it?
Right.
Are they puzzled by it? If that did happen, then they don't want to tell anybody that that's what they happened, because part of the reaction is part of what they're looking to find out how it happened.
Right. Yeah. The whole thing is it's a
experiment.
stress test.
Yeah.
You're trying to figure out, okay, how are we going to respond? And so you create the circumstances where you can measure your own response, to
Exactly.
something.
Yeah, and one of the things to keep in mind about actually both military and commercial pilots, their job is not to investigate funny things out their window.
Right.
If you're a United pilot flying from Newark to Chicago, you see something weird out your window, you go and announce to the people on your plane, we're going to be an hour late going into Chicago. I'm going to circle around and look at that weird object from some other side. That is your last day as a pilot. And if you're a military pilot, you are being timed constantly on how fast you get from point A to point B. You are not trained, and your sensors are not set up in a way to collect data.
It's not
to
Star
understand.
Trek.
Right.
You're like
To boldly go to seek out
To
new
seek
life
out new life. No.
and new civilizations.
Yeah, because every minute you're up there, there's millions of dollars that cost millions of dollars to keep you up in the air.
the military's job is to protect the country.
Right.
Their job is not to study unidentified scientific phenomena. Right? That's NASA's job.
Tell me about this new phenomenon that was identified by the crowdsourced observations of phenomena in the sky.
So one really interesting phenomenon are sprites.
Tell me about it.
So lightning sprites are something that
That's a new flavor. Soft drink.
it's basically upward going lightning, 10 times more common than regular lightning. Pilots would report seeing this stuff, but they were so fast that people dismissed it. And it turns out to be a really common phenomenon. And go into images Google, type in lightning sprites, SPRIRTE, like the old soft drink.
Okay.
You'll see amazing images. And these images were dismissed until we developed the technologies to get fast enough images that we can get lots of images of sprites.
Wow.
Oh, because they're very transitory.
They're really
So
fast.
it's very hard to, what is that? And you get your camera, it's gone.
It's gone. It's
gone.
Right,
Right.
okay. So the crowdsourcing or encouraging people to document what they see in whatever way they can, whether or not we discover aliens, we might discover new science.
I mean, there's some amazing things out there like St. Elmo's Fire, ball
That's
lightning.
a movie. That's a movie.
It's a good movie. A little nostalgic, we're showing our age. But like,
Well, wait, so St. Elmo's Fire is the discharge at the top of a ship's mast.
Yeah.
Right.
And it was glow, and it was, oh, that's beautiful. No, dude, you're about to get hit by lightning.
Lightning. Say goodbye.
so yeah.
Can you
phenomenal.
explain ball lightning, please? I've heard of it. I've never even seen like pictures of it, but
So it's a ball of ionized plasma, so like gas that's so hot that there's free electrons moving around.
Okay.
It persists for a while. Like one of the scary things that I've heard of is like there was an incident on an airplane where this ball of lightning rolled down the aisle of the plane and then left.
How did it get in the plane?
It came in a window or the side. I don't know.
The plane is a closed
It has
thing.
a travel agent.
It wanted first class. Wait. I just understand something. The plane is made of metal. How are you going to move ionized material through metal?
I actually don't know how it got in. I mean, there's a report, and again, this is something where
Because eyewitness,
eyewitness
you work it
report,
as you can.
You work as you can.
Because a plane on some level is almost a Faraday cage.
Yeah,
Right?
and people have reproduced this phenomenon. It might be a tangled piece of magnetic field with a plasma on it.
Holy
we
moly.
don't quite so ball lightning. I'm not expert on this. My understanding is it's still not well understood.
Okay.
Okay. Cool.
So there's stuff out there that that are just amazing things we don't fully understand.
So I'm going to paraphrase Hume, I think it was, on the subject of miracles, where it was the likelihood that it could be some new law of physics you're witnessing is greater than the fact that it's actually a miracle that
transcends physics
that
itself.
transcends the law of physics itself.
Gotcha.
Right. So in this case, if we're going to see a phenomenon that is just completely weird and we never had the way to capture it before, it's more likely a natural phenomenon that's new to us than visiting space aliens who were eavesdropping.
I think as scientists, we should be guided by wonderful quote by Galileo. Measure what's measurable and figure out how to make measurable what you can't measure.
Oh, wow. Look at that. That's a great. That's great.
Okay, but that's not his best quote, though.
Okay.
You got
You got one better?
Yeah.
Go ahead.
The Bible tells you how to go to heaven, not how the heavens go.
Ooh.
He could rap that
Yo,
one.
let me tell you something. That's a mic drop right
That's
there.
a mic drop.
Yeah.
That's a good one. All right, so David, we got the smartphone. Is there some other ideal device you can imagine deploying for people that would get better data than the cell phone itself?
I think I would really start with the cell phone because we don't know what the phenomena is.
Right.
So you don't invent some new expensive technology when everyone's carrying a cell phone around in their pocket.
But as astrophysicists, we invent new kind of telescopes all the time. They have new detectors, and so even if we don't know what the detector is going to find, so why deny something similar to the public?
Because how are you going to put that in the hands of everybody?
Because I think for
You can't
me,
carry a 100-inch telescope on your back. What?
yeah, I know. One of the big concerns I have right now is this issue of scientific trust.
Interesting.
Right? People don't trust scientists. They think things are hidden.
Right.
I feel it's important to also address the question of like the sense of conspiracy, the sense of something's hidden, and that by involving the public in acquiring data, looking at data, understanding
That's the
data,
most transparent thing you can do.
you want to be transparent, you want to be open, especially when there's a sense of hidden conspiracy.
I think that's great.
Okay, so I have a very
Yeah.
bad segue. Things that are hidden from us that we want to reveal. One of the longest unsolved problems in astrophysics is dark matter. And there's a telescope soon to be launched, the Nancy Grace Roman telescope. Did I say that right? Remind me who she is?
So Nancy,
She was a lady on HLN. She talked a lot about crime. I'm sorry. Go ahead. I couldn't help myself.
so Nancy Grace Roman was the first head of astronomy at NASA.
Oh, cool.
Oh,
So she was one of the really early pioneers.
Just to remind
building
people,
NASA.
NASA launches things into space and conducts science as a whole separate kind of avocation for the agency. So somebody can head the astronauts go into space and a different person is heading the science.
Right.
Okay.
So think about the person responsible for things like the Hubble telescope
In modern times.
in
yeah.
modern times. You know, she did some of the first things that would the precursors to the Hubble telescope, the precursors to the James Webb Space Telescope, right? So, you know, just like there were the Mercury astronauts, right? At the time you're doing the Mercury astronauts, she is thinking about and leading NASA's efforts to start to do astronomy.
And so what is that telescope tuned to detect?
So it is set.
And what's your role on that telescope?
So I helped lead the science team for it when we started. I helped lead the design of it. I kind of was one of its early advocates to make the case first to the scientific community and then to NASA and Congress that we should
we don't
build
do anything
this.
else. We have very good buy-in from the whole community. We're we're pretty tight in that way. I'm very proud of us.
Is that to avoid infighting?
Yes. No, if we infight, it's only among ourselves.
Good.
But when we have to beg for money,
Right.
we're pretty tight.
You got to be tight.
We're tight on
Yeah,
that.
and it's going to basically map the entire sky with the resolution of the Hubble telescope.
Holy crap.
So you've seen these Hubble images, and they're just amazing.
Yeah.
Imagine you can map the whole sky that way. So it's a Hubble quality image, but a much bigger field of view. It can see much more, and it's sort of more advanced technologies. So it'll let us map the whole sky.
So what's the difference between that and the Vera Rubin telescope, which also has very wide field mapping of the sky?
Right. So the Vera Rubin telescope will operate in the optical. It'll do
So
amazing
visible light.
Visible light. It will do amazing things, but it is still limited by our atmosphere. So this will be in space. So it'll operate in the infrared. It'll be sensitive. It'll be a very nice complement, actually, to the Rubin.
And as a reminder, infrared doesn't make it to Earth's surface very
Right,
nicely. So
right.
And it doesn't
That's
make
why
it
it's
to the
better in
Earth's-
space, right?
Yeah. Doesn't make it to the Earth's surface, and lots of things in the Earth's atmosphere are glowing in the infrared.
Yeah.
So you really gain a lot by going to space, and you'll have much sharper images.
Yeah.
And I think its legacy will be incredibly broad because you map the whole sky. We're going to discover stuff we hadn't expected. I mean, whenever you point your telescope in new directions and new ways, nature surprises us.
Plus, I have to put something to rest here. There are many people who think that you miss something if you don't expect it,
Right.
okay? You only will see what you expect.
Right.
As a scientist, if there's something I don't expect, that's the first thing
you see.
Oh, it's like, oh my gosh,
Right.
I don't know what that is.
You don't have search bias.
That's it. It is something
Yeah.
I've never seen before.
Right.
Oh my gosh.
Looking for your keys and you missed the $20.
So an example I think of is you will come and visit New York City. You come to New York because you want to see the tree lighting at Rockefeller Center.
Okay.
And that's like your plan. I'm going to go there. And that experience is worthwhile. And you see it, and that's like we designed the telescope to study dark matter. We designed it to study nature, dark energy. There's some particular things we're going after. But as you go to Rockefeller Center, the best part of that trip to New York might be someone rapping that you hear in the subway. It might be some person you happen to meet. It might
Elmo.
be the bar you might be Elmo. Hopefully, it might be Elmo in Times
the naked
Square.
cowboy.
Or the Ray.
Or it might be some band you heard at a bar that you went to late at night.
Yeah.
And yes, you went to go to Times Square. That, like, you know, when you made your airplane reservations, you planned around getting to the lighting of the Christmas tree. But it's
But
everything
what was
that happened.
unexpected ended up being so much better.
Yep.
Yeah.
Yeah.
And that's,
Or more interesting.
Or
yeah.
more
Yeah.
interesting.
you know, and in some ways, that's been the history of astronomy.
Okay.
If you've never seen the Christmas tree at Rockefeller Center and the lights on Fifth Avenue in the stores, go. It's
Right.
worth going.
Even if you're Jewish, go.
Yeah.
It's
Yeah.
interesting.
No, I say that as a Jew.
And I was in one of the panels that was establishing, scoping what the expected science would be from the Hubble telescope.
Okay.
Because we're old enough, we predate the telescope itself. And so you're not going to design a telescope unless you have a plan for what this sucker is going to look at and what it's going to, questions it's going to answer. If you look at that document today, most of why we remember the telescope has nothing to do with anything that was forecast for it.
Right.
Most of it. And that's the real testament to a fertile bit of scientific instruments, right? So there's a clear difference then, of course, between the Vera Rubin telescope, which is ground-based,
Right.
which means NASA has nothing to do with it. We just have ground-based money and ground-based people doing it.
All over the world.
And the Nancy Grace Roman telescope, spaceborne telescope, which is now, it's just amazing we can just speak of that casually. Well, another space
telescope.
Yeah, that's great.
Exactly.
Oh my gosh.
Right.
Very cool. Now, we're not the only players in town. We got Europe, the European Space Agency, ESA. What are they working on right now?
So ESA launched Euclid. It's up there in space now.
Euclid.
It does many things. In some ways, it's a smaller version of the Nancy Grace Roman telescope.
Okay.
It's up there. It's not as sensitive. Its resolution isn't as good, but it's still the most powerful thing we've had up to now.
And it's operational right now.
It's operational now. It's taking data now. They are still calibrating and understanding the data. They have not made most of the data they're taking available yet. They will.
Just to be clear, when you have data, any data you have has to be calibrated. Without calibration, the numbers mean nothing.
Right.
Right. It's a very big part of what
It's
we
like
do.
trying to weigh yourself.
Well, if you don't know, if you just get a scale and just throw in some springs,
right.
you have
You
no,
have no
idea.
idea.
What are you calibrating against?
Right.
And the press never talks about it. The public doesn't know anything about it. And it's half of our effort to calibrate and characterize data.
Interesting.
Not his. He was a theorist.
Well, no, I
You
work.
know, I invited him to the telescope in Chile
And there was an earthquake.
when I was doing my PhD thesis. And he's a theorist. There was an earthquake.
Not just a earthquake, a Richter 7 earthquake.
And it threw my spectrograph off the thing. I got data. I don't know what I was looking at. And I said, so these are the observer gods saying we don't want theorists up here with us.
You just blamed him for an earthquake.
Yes, I did. I'll take full responsibility.
What the hell were you doing there anyway? I forgot.
I went for fun.
There you have it.
All right.
You cannot argue with that answer ever.
Okay.
So, Euclid is actually a collaboration between NASA and ESA.
And that's how you can get connected to Euclid as you are.
And, a lot of these things, NASA and ESA work together. So NASA built the infrared detectors that are on Euclid.
That ride on it. Okay.
Okay.
And with the James Webb Space Telescope, one of the most important instruments was built by the Europeans.
All right.
So we really do work together when we can.
That's a science thing because politicians haven't figured that out yet.
Yeah, unfortunately.
Just saying.
This is why you guys should be running the world, but you're too busy doing your science.
So, David, we came of age where just before us, there were the observers and the theorists. And the theorists, you give them a pencil and a pad, and the observers would go off to telescopes. And then the power of computing became manifest to both branches of our field. And the theorists started using computers. The observers started analyzing data more thoroughly, more quickly. And so does the phrase computational astrophysics mean something specific and different from how that evolved out of those two branches?
It's basically those two branches. So when we did theoretical work and started from how we thought the universe began, worked it forward to predict what galaxies were like, we did what we could by pen and paper. And then you reach a point where things start to get complicated, and we couldn't carry out those calculations. So we started to rely. You do what you can. You do what you can. And so you start to rely on computers to let you do calculations that you couldn't do otherwise. And those computers have gotten more and more powerful. So we can now do detailed simulations of how stars form, how they evolve, how they explode.
So they're not just you're not just computing formulas. You are running simulations of the universe on timescales that we don't live long enough to see.
Wow.
And you can do it on the computer.
That's awesome.
No, it is.
I love that.
And you know what happened in our lifetime? I got to tell it. Let me tell the story. Just in the generation before us, there was a very important observer, Chip Arp was his name. Halton Arp is his full name. And he compiled a volume of galaxies that just looked weird. Okay? And it was called the Atlas of Peculiar Galaxies.
Cool.
And they were a trove of, if you wanted to study things that were just different,
Right.
from the north, you pick objects out of that catalog and bring a different kind of telescope to it.
Right.
But no one knew how they came to be. What are these things? Is this a new kind of formation process in the universe? Because they're all just weird.
Oddly shaped galaxies.
Oddly shaped. And then there was a movement once we could bring computers, and we noticed that some galaxies were far apart from each other, others were closer, others were like just touching. So no, wait a minute. Suppose we simulate two galaxies colliding.
Oh,
What would that look like?
galaxy sex.
And all of a sudden, galaxies were train wrecks. And then these objects in the catalog came to life.
Right.
So they weren't a different kind of object. They would just, so as one of my mentors, Gerard de Vaucouleurs, said, these, a Lexus that's been in an accident is not a different kind of Lexus. It's still a Lexus.
That's very,
that was
very
perceptive.
good.
So that was an entire branch of our field that was resolved and burgeoned into a whole understanding of colliding galaxies because of computational astrophysics.
I think the history of how stars evolve and the lifetime of stars was really the first big triumph of computational astrophysics.
Okay.
This actually goes back to the 50s and 60s, the very first computers were able to take
The
a star,
military and scientists had the first computers, right?
Makes sense.
take a star like the sun,
Right.
and the laws of physics we understood, but they were complicated laws. We couldn't do the full calculations by hand, and evolve them forward and describe what happens, and then that matches the patterns we see in our galaxy.
There you go.
So
And
like,
this gives you the confidence, right?
Yeah.
Because the laws of physics are everywhere.
They're going to be the same.
They're going to be the same. So you run it.
So you run the simulations, they match up, and you're like, okay, we're on to
got
it.
this,
We
yeah.
got it.
Yeah,
That's
so-
really cool.
so that's the first part, is as it takes theory and supercharges it, lets you do calculations you couldn't do before.
A quick add here. One of my colleagues in my department here does computational astrophysics, but he specializes in gas. Like, it's one thing to have a star and a galaxy and this, but gas, an amorphous gas.
Yeah, which is
how do you
so much more
how do you model
weird to model.
that?
Right.
Right, because it's not discrete objects.
Right.
It's a continuum of medium. And so that's a whole other thing.
It's gas, and it's filled with magnetic fields, and there's explosions
you.
propagating through it.
Shockwaves.
So it's really rich physics, and we're still struggling to understand it with our simulations. And of course, the other piece is observations.
So, David, what is the latest understanding of the dark matter problem, which has been with us for nearly 100 years?
So we don't know what makes up most of our universe.
Okay, that's it. We're done here. You heard it here first.
Atoms make up about 4 or 5% of the universe,
And we're made of atoms.
and we're made of atoms. Everything we see is made of atoms. Dark matter is 5 times as much of it. It's something that's there. We sense its gravitational effects.
Okay.
We don't know what it is.
So I wanted to lobby to call it dark gravity, because that's what it literally is, because you don't know if it's matter, if you otherwise can't interact with it.
We don't know if it's matter. It acts like matter
No,
in the sense that when it experiences gravity, it clusters. So we see it cluster in galaxies. We see it behave.
Wait. What do you mean is clustering in galaxies? If it's 5 times the matter we see, it's the galaxies that are clustering in it.
It makes up most of the mass of our galaxy. When we see its behavior in different ways, it's behaving, it experiences gravity, it falls, it generates gravity, but it also experiences gravity. So that's everything's like that. The Earth experiences
gravity
the sun
and
gravity.
creates gravity, right?
We can see the Earth.
The sun feels us.
Right.
This has been the history of science. We felt the gravitational effects of Neptune. We didn't know it was there yet. We then went out.
This is very royal we here, because he's talking about the planet Uranus. We felt the effects of Neptune.
Uranus
felt the effects of Neptune. Yes.
And we, being astronomers in the 19th century who did the calculations, realized it was there, saw it. And then Mercury, we also noticed it was experiencing something weird. And in fact, they thought maybe, hey, an idea worked once, let's try it again. They predicted the existence of the planet Vulcan.
Yeah, we've done a whole show on Vulcan.
Right, we did.
We're Vulcan fans here.
And it turns out it's not Vulcan, it's general relativity. So we don't know what dark matter. Is it a name we're using to describe some new particle that we haven't seen yet?
Right.
Or is it a name that we're using to describe the fact that general relativity is breaking down? and we need something beyond
that.
We just don't know. So
don't know.
you were not very helpful in this question. I thought you had an answer.
What we have learned is what dark matter isn't.
Okay.
Oh,
That's a start.
That's a start.
Yeah, yeah.
So, this is kind of like Sherlock Holmes.
So it's not black holes.
It's not black holes.
Right.
And I attended a lecture you gave one time, and you also gave evidence that it's not lost socks.
It is not lost socks.
Okay.
It is
That's good to
On
know.
my drawer, I have like
Yeah.
4 or 5 socks that don't have
What's
pair.
the deal with the one sock? Okay.
It is not like a bunch of rocks. It's not, we know we've eliminated a whole bunch of things. It's not a massive neutrino. We've just kind of gone working our way through the list of
Okay.
things we know.
Well, it's good to eliminate,
That's how you figure stuff
Yeah,
out.
exactly.
You eliminate possibilities until you figure out what's there.
Right.
As Sherlock Holmes did, right?
Exactly. And then dark matter is just the beginning.
Right.
There's also dark
Energy.
which is energy associated with empty space. And it dominates the universe, will determine its fate, and we don't know what it is.
And it means space ain't all that empty.
That's right.
Look at that.
So what else has Simon's done with his money?
So one of the things we're building in Chile, we just got first light.
And Chile is a country that happens to lay right on the
So
Andes
long
Mountains.
and yes.
the Andes Mountains. So in Chile means it's up in the Andes Mountains. Yes.
So it's at 17,000 feet,
Ouch.
Great elevation.
really high dry site where we're
But
studying
just
the-
to be clear, Keck is at 14,000 feet.
Okay.
This is higher than the
than-
Keck telescope
Look at
on
that.
Mauna Kea, Hawaii.
So we're using that to study the leftover heat from the Big Bang,
Ooh,
the microwave background.
excellent.
And we'll be using this to, if we're lucky, we will detect gravitational waves from
From the
early
very
universe.
beginning.
Yeah.
Wow.
And learn more about how the universe began.
Okay, but at 70,000 feet, no one's breathing any air there. So it's all surface observing.
No, 17,000, you go up and you bring an oxygen tank.
Look at that. Everybody up there looks like they're in a nursing home.
All right.
Oh, I gotta tell you.
So one of the things of being at altitude is you're dumber and you don't know it.
Wow.
So people at altitude,
That is when you have less oxygen.
Because you're oxygen deprived.
you're oxygen deprived. So you have these things where people are working at the telescope and they're telling you what they're doing, but they're communicating with people back at sea level. And they're like giving you really stupid suggestions. And you turn to them and say, can you add 5 and 7 for me?
And they're like, yes.
Yeah. And they
It's cupcake.
it's like, I think one of us is at altitude. Let's think about this some more.
It took a
Right.
hit on some oxygen.
Yeah.
So it already has first light.
So we got first light. We'll be starting to collect data, start the science run soon.
Okay.
We will be looking for these gravitational waves. We will also measure in much more detail the patterns of polarization and temperature we see in the microwave background. That'll let us determine the age of the universe, its composition, to much higher
Wait a
precision.
minute. But you're not a LIGO type arrangement. So you're going to detect a gravitational wave. This is not the observatory where you're going to look at the wave move across pulsars and see the timing difference?
Nope. That's yet another way of seeing gravitational
Can you
waves.
imagine? Can you think of that?
That's actually seeing the wave.
Yeah, seeing the wave move from here to there, affecting the data that comes
Right.
back from pulsars.
As opposed to LIGO, we detected it wash over, right?
Watch over it.
Yes.
But here we're going to watch it
Watch it
go through the
actually
universe. That's some clever people out there, dude.
So what we're doing is we're using the early universe itself
Right.
as a gravitational wave detector.
That's amazing.
So the gravitational wave comes along. It moved electrons 13.8 billion years ago. Those electrons, because they're moving, scatter light in a predicted polarized pattern. And we look out in space, we look back in time. So we're looking back, seeing how gravitational waves moved matter around 13.8 billion years ago.
I don't understand how you cannot love science when you hear this kind of stuff. How can you sit and go, oh, who cares? Like, what is your problem? Okay? That is unbelievable.
So it's a clever way that involves a completely different scheme to detect a gravitational wave
Right.
than LIGO.
It means we're detecting gravitational waves whose wavelengths are comparable to the size of the universe.
Okay.
And that lets us know
Chuck
about
just
the
blew a
universe's
gasket.
beginnings.
When Chuck goes up 3 octaves, we know he blew a gasket.
Because it's always so simple. It's like, it's so profoundly and brilliantly simple, but yet like beautifully and elegantly complex at the same time. It's unbelievable.
Okay, I think we have enough brain filling
Yeah, man.
for a day.
Oh, that was amazing.
From aliens to wavelengths the size of the universe.
Yeah.
I think we're full for a while. When you think of science, of course, you think of scientists sometimes burning the midnight oil or even collaborating, coming up with a new idea, a new observation, a new measurement. And occasionally, if it's really different and groundbreaking, it makes the news. And this is our general understanding of what science is and how it unfolds. However, if you part the curtains, somewhere back there are agencies, there are organizations, there are funding streams that enable the science in the first place. When I say I'm a NASA scientist, if I were to say that, that means there's money back there voted on by Congress, members of Congress voted into office by the public, that is the point of origin of the funding that enables it in the first place. And so when you hear about science funding agencies, I want you to think of them as fundamental as the science itself, because without them, there is no science. Yeah, you can be in your garage, I suppose, but lately, not much happens in anybody's garage. Science, the greatest of science that unfolds today, are major collaborations with telescopes and particle detectors and collaborations that are not only domestic but international. And so it's the juxtaposition of those two that makes science move. And that is a cosmic perspective. All right, David, it's a delight to see you again. Chuck, always good.
Always a pleasure.
All right. This is StarTalk, Neil deGrasse Tyson. As always, bidding you to keep looking up.